Hello, this is the second video in the Graph and Networks 2 series for OCR Discrete Further Maths. It covers finding a minimum spanning tree from a table or matrix using Prim's algorithm. Prim's is an example of a greedy algorithm in that it maximizes immediate rewards without considering future choices or consequences. Therefore, it only looks at the arcs connected to the vertices already chosen. We have already seen how it works when we have a network diagram. The network may be given in matrix or table form, as this is the most useful form for computers to work on. We could reconstruct the graph from a table, but this is generally inefficient, especially for large networks. Let's look at an example. Here we have a table showing 5 nodes A through to E. If we have a look at Prim's algorithm, we can see from a table, we can see that we choose a starting node and we number that column 1 and delete the row. So I'm going to start with A and I'm going to put a 1 above the A, and then I'm going to put a line deleting that node. Don't forget that the starting node may be given in the question, so do read it carefully. I'm now going to look down all the numbered columns, in this case just A, and just choose the smallest value that is not crossed out and circle it to show it's been selected. Well, in that A column I can see that that is the smallest value. So then under here I'm going to write AC and a 1. If I wanted to as well, I could start drawing an MST. Doesn't matter that I don't know what the original network looks like. So I now take the node corresponding to the entry I've just selected, in other words C, and I label its column with the next number, so number 2, and then I delete its row. Crossing out a row means that you can see that the vertex has already been connected, and this helps me avoid making any cycles or closed paths. Moving on then to step 4, I keep repeating steps 2 and 3 until all the rows are used up. So I'm now looking down column A with the 3, 5, 4 and column C with the 2, 6, 3. And I'm going to choose the smallest in either column, which happens to be CB at 2. So then I will label column B number 3 and I will cross out the rest of the row B. I am now looking down columns labelled 1, 2, 3, A, B, C, and I'm looking to see the smallest entry. Well, I can see that that is CE with a weight of 3. So I will label column E with a 4 and cross out the rest of that row. I now just need to connect D, so I can look down all the columns and I see that the smallest one is the entry DE of entry 1, and I would then cross out, delete that row, and I do put a 5. I do need to continue and show all of that working. I could then add up 1, 2, 3 and 1 and know that my MST is of length 7. And if need be, if I was asked in the question, I would have an MST drawn. Here's another example from a table. You may wish to pause and try this for yourselves. Again, I'm going to choose a starting node carefully, reading the question to see if they give me one or not. And if not, then I will probably start with A. So in this case, again, I number A with a 1 in terms of a column, and I cross out the row. I look down A and I see that the smallest one is AE. So I would write that down. I'm not going to draw the network as I go along this time because I haven't got room, but generally speaking I would choose to do that in the margins. So E then becomes a 2. I look down the 2 columns and I see that the smallest one is EF. So F gets a 3, and then I delete that row. I look down the column A, E and F and I can see that the smallest is ED with a 2. So D column would be labelled a 4, and then I would cross out the row D. Looking down again, this time I'm looking down all 4 columns, I can see that the smallest one is CD at a 1. So that then becomes my 5th column, and I cross out that row. And then I can see that the smallest way of connecting B is to say CB at a 2. So therefore I add the 6 and I cross out that column to complete all of my working. Remembering that a computer using an algorithm will not know to stop until all the rows are used up. I can then see that the minimum spanning tree, I could draw that using the arcs in the order I've connected them here, and the weight would be 1, 2, 3, 4, 5, 6, 7 again. So in the exam, try and remember to take a ruler in so you can do that neatly. Fortunately, I don't have a ruler on this video. The common errors in applying this method, so for Prim's algorithm from a table, are pretty similar to the errors made when we do Prim's algorithm from a network. Obviously, not reading the question or starting at a specific node, but with a table you must remember to delete the rows. This avoids creating closed paths or cycles. So if you don't delete a row, you might possibly choose another arc connected to a vertex already chosen by mistake. Do look down all the numbered columns, otherwise you might miss a shorter arc. Please record the order of your arcs as you go along, as it's more difficult to tell from the table at the end and you have to do all the work for it all again. Do show all your working, do number all the columns and put a line through all the rows. Please don't forget to state the length and weight of the MST at the end. In the next video, 2.3, we will look at minimum spanning trees again, but using a different algorithm by Kruskal.